So they want us to find the difference quotient of f of x equal to negative 9x plus 2. Okay, so the formula they want us to use basically is this here. F of x plus h minus f of x over h. So what I recommend is do this in steps. So find this part first and then subtract f. And once you get that, divide by h. So here's f. So do you guys remember when you have something in parentheses, what you're supposed to do? So the difficulty of these questions will depend on what f is. If it's something simple, I mean, the steps will be the same, but the algebra will vary depending on what f is. So right now, remember, if it's in here, you plug it in, right? For any x that we only have one, so it's not too crazy. But negative 9 times x plus h plus 2 is going to give us negative 9x minus 9h plus 2. So there's this piece. Step 2, find what you just got minus f. If you want to do it all at once, you can. I'm doing this just in case you're not familiar with this and your algebra is a little rusty. Okay, just in case. So I already found this in the previous step, so here it is. And then we're going to subtract the entire f. Negative, to distribute your negative, double negative is a plus. Negative becomes 2, positive becomes negative 2. You guys cool with the algebra so far? Is that okay? Okay, so step 1, any questions on step 1? Right. We plugged in x plus h into this x, distribute the negative 9 onto both. Give us these two terms, and the plus 2 is just hanging out. So then they said, find this minus f. Well, this is right here. So there it is. Minus the f, which is right there. So negative distributes on both. Double negative makes this positive. 2 becomes a negative 2. Now we combine like terms. So yeah, it looks like a lot is going to cancel out, like you said, Adrian. Yeah, everything's gone except this guy. Because negative 9 plus 9, 2 minus 2. Any questions on step 2? So now they just want us to divide by h because we already did top part, right? So that'll be This is right there, just an arrow. Yeah, so this is the difference quotient. So what they wanted was this. Any questions on any of the steps? So the next one is the same question, but the function is going to be annoying, so it's going to be harder. To find the difference quotient for, oops, sorry, F is going to be this guy. So you can see since it's a rational type, it's going to require fraction stuff, and that can be difficult. So step one, find this guy, plug in your x plus h, x plus h. Step two, take the one we just found, right? And then subtract the original. So this is where it gets kind of annoying. Oops. So these are prime numerators. So well, how do we subtract them? Right, we need the LCD, right? LCD is just going to be a product of these two because they're prime. So take the first one, the first fraction, and introduce this guy. And then this one multiplied by the one that's missing, this guy. That way the denominator of both of these will have the same thing because I'm going to introduce what this one has to here, right? And I'm going to introduce what this one has over here. Does that make sense? Like if there were numbers, you would just multiply top and bottom, right? or no? I mean, it's not gonna, it doesn't look pretty, but do you see what I did, or why? Yeah, it's a little difficult if you don't remember rational expressions. So we'll come back to that in just a second. So like, let's say I had 1/3 plus 1/7. These are both prime, so that means that in order to add them, I would introduce a 7, and I would introduce a 3, right? So this would become 721 plus 321. Now I can add them together to get 10. Does that, y'all remember this stuff, right? So the same thing, because they're prime, 3 and 7, then I introduce this one needed a 7, this one needed a 3. That way they could become the same. Once they are the same, add them together. So same concept over here, except it looks ugly. These guys are prime, so I'm gonna introduce what this one's missing. This one's missing an x plus 1, right? That's kind of like I did earlier, like with the 7. This one's missing the x plus h plus 1, so there it is. So now they're gonna have the same denominator, so I can subtract them or add. It'll be the same. So you'll get to here. I'm not gonna actually multiply just yet. Adding an extra step just in case. So now we have the same thing going on. I should move that towards the center. There we go. Now, are you still with me up to this point? So here we're just gonna have to multiply stuff out and see what cancels. It's just yeah, it's just ugly. Okay, so I distributed x times x, x times 1. Get the first two terms. H times x is xh or hx. H times 1 is h. Negative x times these three gives me these three terms. You see what I mean by depending on the function, this stuff gets harder. So the first one was easy, or a lot easier than this. It just depends on the function. The x squares cancel, xh cancel, and the x cancel, leaving me with h. Okay. Yeah, I'll see the cancellation. That okay? I know it's algebra intensive, but it's okay if you have a question. It's tedious. Okay. So that's step two. Step three, I need to divide by h. You see how the h is going to cancel, and that's pretty much it. Step three is pretty short. Okay. Do you agree that dividing by h is the same as multiplying by 1 over h? So this, you see how they're going to cancel, right? Right here we get, put the h in the back or in the front, doesn't matter. It's going to cancel. Well, you can cancel it right before if you want, but that'll be it. Our difference quotient will be this. Any questions on any of the algebra? Does it make sense? Is it okay? You'll see some of these on the homework. You probably won't see that on the test because it's kind of annoying, in my opinion. It's too long, but homework is fair game. Homework is when you get the interesting questions, but the exam should be more like the first one, or a little harder maybe. Okay, so you're good on number three. So four, I don't even know if it's worth it. Well, yeah, let's go ahead and do it, I guess. Suppose that functions, I'm going to use f and g. The homework in the book uses s and t, but my s looks like 5 and the t looks like plus. I think that's a bad idea. All right, so suppose the functions f and g are defined for all real numbers x, and f is 2x squared, g is x plus 5. So here they're going to do a little bit of algebra of functions, but it's not that hard. It's more like, do you understand the notation? So find f plus g of x. So if you see this notation, what they mean is this. Just add them separately together. So if you see it written like this, you're just saying add f and g. You're done. So that would mean take this guy and add this one. There's nothing that combines, so we're done. They also say find, we'll call it part A, I guess. If they have times, that's the same as saying f times g. So that'll be 2x squared times x plus 5. So here we have to distribute a little bit. 2x squared times x is 2x cubed. 2x squared times 5, that'll be plus 10x squared. Any questions on the times? Difference, just subtract them. So that'll be 2x squared, that's f, minus g. Since there's two parts, you have to distribute the negative on both. So be careful when you do this. Be careful with your signs at all times. You should get this. So is there any question on this notation? If you see plus, times, minus, or division, do you see what they're asking? It's not supposed to be crazy. It's just, do you know the notation? Do an extra one because I forgot the number. If they plug in a number like this, they mean they want you to plug in the 2 into both functions and then subtract. So that means f of 2 minus g of 2. So find those answers and then subtract. That'll be 2 times 2 squared minus 2 plus 5. That'll be 4 times 2 is 8 minus 2 plus 5 is 7. Be 1. So no question on A, B, C, or D. Okay. Let me show you the next one. I'm not going to work this one out because it's the same thing, but check it out. So given two functions, r and s, r is x plus 3, s is defined as 4x squared. Find s plus r, x, s minus r of x, s times r of negative 1. So remember, this is what they mean, right? It's what I wrote out earlier. So s plus r means add the functions separately, just like that. And nothing combined, so that's it. Cool. We're done there. Minus, just be careful with your minus sign. Apply the negative to the entire r function. Right there. Both become negative. And nothing combined, so we're done. The times but at -1 means plug in -1 to each one, get the results, and then multiply it together. So the results, remember, S is this guy, so plug in -1 here. R is that guy, plug it in there. The results is 4 and 2. All right, we're gonna move on to something else. Just want to at least talk about one more. So the same thing. Let me go back to the paper. So let's move on a new topic, the composition. All right. What number was this? 9. One more problem, 9. So given f of x and g of x, find part A, f of g of x, part B, f of g of 2. So they're basically putting the g inside the f and see what happens. And here they're saying, well, plug in the 2 into G, get a result, and that result will go into F. Let me give you the definitions here. So composite, here's a note. The F composed with G, if you see it written this way, it's like a little circle. It's not an O, but it looks like fog. That means F of G of X. If you see the other way, G of F, that means G of F, so put the F inside the G. Does that make sense? Do you see what they're asking? By the way, F, we have to give the F. All right, so that's F and G. Part A wants you to plug in the F or the G into the F. And we said whenever you have something inside the parentheses, that means replace all your x's with whatever that is. So this x here will become x squared plus 2. So you get there. Okay. So that becomes negative x squared minus 2 minus 1, which is that. Hmm. Now, once you have the general function, you can plug in the 2 into this one, and it's the same as plugging it into the g first and then the f. So if you have the general one, then this is for any x. X can be anything as long as it's defined, so you could plug in the 2 here. But if you want to show the steps so you can see, right, f of g of 2 means f of 2 squared plus 2, which is f of 4 plus 2, which is f of 6. And f is negative x minus 1, so that would be negative 6 minus 1. Does this notation make sense? That okay? Okay, so you're cool on number 9 then. It's kind of easy. Now, I'm trying to find one that's a little harder. This one's kind of in reverse. Maybe this was more interesting. Uh, Here. Let's follow the solution together. So they're saying, suppose this new h function is this cube root of 2x squared plus 2. Find the two functions such that f of g of h, I'm sorry, f of g of x becomes h of x. So can you tell by looking at it, right? What's the one inside? I mean, you see there's an inner function, right? So basically, this is what's inside the g. So what is g? Can you tell by looking at this? And what is the outer function? I see how they've already given us the composition. So this is like saying f of this garbage. Does that make sense? Oh, we're kind of reversing the composition. And you see why the outer function is cube root, and the inner function, which I think should be a little more clear than the outer, is this guy. Okay. All right then. I guess we'll stop there for 2.8. You guys have any questions on 2.8? You'd be cool with the notation for composition or the algebra of functions, the subtraction, addition. So the main three things today was, or for this section was the difference quotient, adding and subtracting, multiplying functions, and composing one function with another. Does that seem doable? All right, let's take a 5 minute break and then we'll start the next section. I think this is the next chapter, 4 point something, 4.1, I think. Yeah. No, yeah, that's what it is. All right, I'll be right back. Okay, so this is 4.1. Um, so do you guys remember when we talked about the vertical line test and whether or not something was a function? So if it is a function, the next question is it a one-to-one function? So basically, that means that every point is mapped to exactly one point, and that's it. So, and every point it has a unique y value. So no other x can go to the same y. So right here we can tell that these are functions based on the vertical line test, right? All of these are functions because it only hits once. One time. My attempt at vertical lines. All of them are functions. But the question is, are they one to one? So if you draw horizontal lines, assume knowing that it is a function and it only hits once, then you would say yes, it is one to one. If you do this one, you can tell not one to one. This one is not one to one. Nope. Nope. This one is because this is a whole, so we're good. This one is not. Does everyone see how to do the vertical line test? So that's all it is like if it's a function, how to tell if it's one to one. We also defined a function last time. We said, well, as long as every point, let's say one, to 3, as long as all these points go to a unique spot, then it is a one-to-one function. Now, if 3 went to this spot here, let's call it A, B, C. This is still a function, but it's not one-to-one because each point does not have a unique output. So function, but not one-to-one. This would be one-to-one. That difference make sense? Assuming this is your domain and range. Okay. So the first one, they just want you, this, well, they want to see, can you define, do you know what the definition is, and can you spot it with graphs? And the only reason we care about one-to-one is because if function is one-to-one, then it should have an inverse. If it's not one-to-one, then you can't find one. But before we talked about inverses, they wanted to find out uh, how to determine if two functions are inverses of each other. And that'll be the case whenever you compose them together and you get an x. So if I were to compose f and g and then g of f, and they cancel out, then it is an inverse. So let me write this notation down here. Let me write down the section. I forgot what it's called. One moment. If f of x and g of x are one-to-one functions, and f of g of x is equal to x, and g of x is equal to x, then f and g of x are inverses of each other. So a quick example. Determine if f of x is equal to square root x and g of x is equal to x squared are inverses of each other. So you just compose them and see if they cancel. And if you end up with an x, then yeah, they are inverses. So f of g means square root of x squared, right? Let me add an extra note here. Whoops. That means f of squared. You see how the square root cancels the x squared, right? And you see how they both cancel? They both give me x, no matter if I compose f and g first, and g of n or g of f this way. I end up with just an x. So since f of g of x is equal to g of f of x, which is equal to x, then they are inverses of each other. So do you see how to determine if they are inverses? So as long as they cancel, you're good. But they have to be one-to-one and defined. If you plug it in and you get some undefined stuff, then it's not going to work. Okay, let me find another question. Okay, so now there's another property of inverses. I'm going to show you and the best way to see it is to read this. Can y'all see the example or no? Okay, thanks. So for a given one-to-one function f, there's a related f inverse. So there's another way to write the notation. So this means f negative 1 means the inverse of f. Um, so basically, In a nutshell, right? What does a function do? It takes an input x and sends it an input x from the domain and sends it to a y value in the range, right? If you plug in an x, you get a y back. And that's what a function does. So the inverse will take the output and bring you back. The inverse will undo whatever the function did. So it's like the square root on the x squared. If I square something, the square root would undo it because they're inverses, which means that the domain of f, and this is a property, I think it's written here somewhere, the domain of f will now be the range of f inverse. See, it's opposite, it flips. So the range of f is now the domain of f inverse. So that just becomes opposite. So this is now, oops, range of f is the domain of f inverse. Domain is the range. Does that make sense? Excuse me. So these are inputs and outputs, right? Input, output, input. So G, if this is the output, what is the input corresponding to -4? Right? So remember, it sends the y value back to x. So if this is your y value, it would give you the corresponding x. So the answer would be 0 because G of 0 is -4. So the inverse G of a -4 would take you back to 0 because it undoes what G did. Oops. You see what I'm saying? Is that is that clear? Or no? So remember, right? The picture, F inverse sends the y value back to the x. So if my y value is -4, what is the x that gave you -4? because it sends it back to the x, right? So it sends it back to the zero. Because what are these? These are all inputs and outputs, right? If I drew you a picture, oops, these are all the, I'm gonna put all the x values and call this the domain. That's what it is. And it's supposed to be a circle, not a potato. And I'm sending them all to the y's. So 5, -4, -9, -5. So what does F do? F sends -4 to 5, 0 to -4, 1 to -9, 4 to -5. So that's what F does. It goes this way. F inverse will do the opposite. It's going to send all these guys back that way. So this question right here, I guess I should use G, my bad. Sorry about that. Yeah. So G of -4 means send -4 back to the X, right? It's going back to 0. Do you see that? Does that make more sense? It's undoing what the original G did. But yeah, that's why it's 0 right there. So what would be, if I were to ask you, or the question, was G of G inverse of -9? What would be our answer? -9 would, yeah, it would be 1. Hmm. And G of 1 would be going the other direction, right? Be -9. Okay. I'll do part B on the paper. It's more involved. But do you have any questions on that first part? Why at 0? Yeah, move on then. Okay. What number was I on? 3. So given h of x equal to 2x plus 9, find h inverse of x. So here's a procedure on how to find it. So for step 1, change h of x into y, like this. Step 2, switch all x and y, like this. Step 3, solve for y. So here we go. Subtract the 9. Divide by 2. Step 4, change y into, because that's what it is. And there's your answer. Is there any questions about the steps or the algebra? Let's do another one that's a little harder. Number 5. So given f of x equal to x squared plus 9, you find on 0 to infinity. So they're kind of cutting the parabola on this section here. Find So here we go. Step 1, change this into y. Step two, switch the roles of y and x. Step three, solve for y. So subtract the 9 over, and then square root both sides. One sec. Where is it? There we go. So we're going to choose the positive here. So there's our inverse and its domain. Because if we use the negative, then it would no longer be here. So when we did plus or minus, I chose the positive. Now, if you graph this, you're going to see something like this. So the domain for F inverse, easy to see once you have the graph. It's going to be bracket 9 till infinity. Are there any questions on number 5? All right. Not too bad, right? For the next one, I'm going to show you a solution to save a little time. If you have questions, we can work it out. No big deal. But let me show it to you first. Uh, Can you all see the example? So this is number 7 in your homework. So they want us to find, so they're telling us it's 1-to-1, which is cool because it needs to be 1-to-1, 1-to-1 in order to get the inverse. The next thing, uh, sorry, I lost my train of thought, is to do the algebra to find it. So here we go. So step 1, change the f into y, and then switch the y's and x's like we did before, and then solve for y here. So they have to cube root both sides to cancel this, which gets us to there. Then you add the 8 over there, which gets us to here. So this is our inverse function here. Once we have that, just graph this guy either on your graphing calculator, Desmos, or by hand if you want, and you'll see the domain. But they didn't ask for it, so cool. They just want this. Do you see, is there any questions on the algebra? Does it make sense? Do you see what they did? Okay. Yeah, I'm hoping it's not too bad. Okay, that's pretty much it, unless you have some questions. So just to sum all this up, given a graph, can you use, assuming that it's a one-to-one, assuming it's a function, can you tell if it's one-to-one using horizontal lines? That's the first thing. You guys cool on that idea? And then given a function, whether it's linear, quadratic, or cubic, or whatever, can you go through the steps to find its inverse, like we did right here and on paper a couple of times? Also, do you remember the definitions and the main idea? F sends an input to the range, right? It takes a value in the domain, sends it to the range. The inverse sends it from the range back to the domain. It undoes whatever F did. F does something, F inverse undoes it. Is that idea okay? Yeah, it's like just undo. Right. So the inverse, that's why we care about inverses, because functions can be anything. And when we apply them to real life stuff or some actual engineering stuff or computer science stuff, undoing something is important, right? It's a especially if it's a complex function. But right now we're just talking about general stuff, general ideas. Okay. Alrighty. I guess we'll stop here. Let me see. We are on. So I'll send this lecture as soon as possible, and I'll try to send you 4.2 and 4.3 as well. If you haven't finished test two, try to get that done this week if possible, because we're gonna move pretty quickly through chapter four. Okay. Alrighty.